All right, so today we're going to look at section 7.3, which is on solving more complicated trig equations graphically. Okay, you can do some of these algebraically, but for today we're going to do it graphically. Okay, so the way we do it is pretty much the way we've been doing it all along. Okay, first, we've got to find all solutions in one period. Okay, in last night's homework, usually for like a sine or a cosine problem, there were usually 2 answers per period. Okay, when we start doing more complicated trig functions, you could have 3 answers, 5 answers. There's even a problem we're going to do with 6 answers in one period. Okay, and all we have to do is remember that those answers repeat every period. Okay, so what that means is once you find all your answers in one period, you need to put plus the period times k. Okay, most of the time the period today is either going to be pi or 2 pi. Okay, that's what seems to come up quite a bit. Okay, so your answer is your solution, okay, that's a number, plus your period, and I don't think we used n, we used k. It doesn't matter what letter you use, but we'll stick with k.
What is that number? Or that letter stand?
K is an integer. So if you had a problem like this, just to use simple numbers, you're saying there's an answer at 4 plus every integer multiple of 4 adding pi to that. Okay? You can't add like half pi. Okay? You can add 1 pi to 4, you can add 2 pi, you can add 3 pi, you can add 7 pi, but you can't add half pi. K has to be an integer.
Go back to the...
Yep. All right, so this problem is very similar to what we did yesterday, except we're not going to do it algebraically. Okay, algebraically, we would take the inverse sine of both sides. We'd get one answer. Then we'd use our diagram. And we'd say, all right, our first answer is in quadrant 1. Our second answer is in quadrant 2. So in quadrant 2, it's 180 minus your first answer. Okay, that's algebraic. Today, we're just going to graph it. All right, who can tell me how to solve that graphically? What do I have to do?
Type sine x and then y1 and 0.8 and y2.
Yeah, type sine x and y1, type 0.8 and y2. And now we want to focus on all solutions in one period. Okay, so what's the period of sine? 2 pi. So what I'm going to do is set my window so that it's exactly 1 period wide. Okay, I don't want to look at a window that's too big. I don't need to. Just find a window that's 1 period. So let's go 0 to 2 pi. And the highest and lowest that sine goes is 1 and -1. So there's no reason to go from -10 to 10. Okay, I'm going to go -2 to 2. And now if I've done this right, I'm going to see exactly 1 period of the sine function. Okay, which we do. Exactly 1 period. And we can see how many solutions we're going to get. Now we just need to find them. And how do I get those 2 solutions? What do I do? Yep, we're going to do our intersect. Okay, and here's our first solution. It's we'll just say x is about 0.93. And now if you wanted to use the trick we know, because we're going to be in quadrant 2, you could subtract that from 3.14. That's your other answer. Or just do the intersect all over again. 2.21? Yep, 2.21. You can do it either way. I did radians.
My first line came out flat.
Yeah. if you're in degrees, then what you'd want to do is set your window from 0 to 360. And then you'd want to go still negative 2 to 2 on the y. Yep. Any questions how you do this in degrees? Okay. The other way you could do it in degrees, if you don't want to change your window, these answers are in radians. Okay. You could just take 0.93 radians, multiply by 180, and divide by pi. And you could just convert your answer to degrees that way. Okay, one of the first things we learned about changing radians to degrees. So you could do it that way too. Any question on how you do it on the calculator?
So you have the rate plus 2 pi k for your answer?
Yes, thank you. Because they said find all solutions. Yep.
So if it's all solutions, there's 2 pi k.
Yes. If they say to find all solutions, you need to put plus your period times k.
But
Yep.
if they just say find, like, is there a case where I would put 2 pi k?
Yeah, they could say find all solutions between 0 and 2 pi. And then you set your x min at 0, your x max at 2 pi, and just find what they ask. Yeah, but that's a good point. If they say all, you got to put plus 2 pi k. Any questions on that?
So if I got 126.86, I did degrees, do I still put the 2 pi k after it or no?
No, you wouldn't put two, you'd put something k, but what would you put if you did it in degrees?
360?
360k. Yeah.
So it's probably easier to just do it in radians.
Yeah, you could do it either way. I'd say most of the time our book sticks with radians. So that's what I'll do. All right, so basically, okay, what we're doing here is we're finding roots, so we're finding zeros. Okay, if we get an equation equal to 0, which I could have done on the last problem, I could have just graphed this, and I would have gotten exactly the same answers. Okay. But instead of finding intersects, I would be doing it as a root. Okay, that's how a lot of the problems are going to be set up. They're not going to put something on the left and something on the right. They're going to give you an equation equal to 0, like this one. Okay? There's no intersects to find here unless you move something to the other side, which we're not going to do. We'll just leave it equal to 0, and we'll calculate the x-intercepts, okay, the roots. Okay, and just as a reminder how you do that, that's under second calc 0. Okay, on some older calculators, they might call it a root, but if you're using one of mine, it's a 0.
How do you remember all this stuff?
How do I remember it? I guess just a lot of practice with it. I've been using the graphing calculator for over 15 years, I guess. And it hasn't changed much. The TI-83, if you have an older one, let's see. This TI-83 and this one, pretty much most of the buttons are in the same spots. You know, if you press different things, I mean, the graphics are a little nicer on the new ones. They're in color, but all the buttons are pretty much in the same spot, so it hasn't changed much. It's a few new features. All right, so now we have to figure out how to find the period of a more complex trig problem, okay, like this one. Okay, well, the way you're going to do it, okay, is we're going to start by finding the period of each periodic term. Okay, so in the problem I just showed you, you're going to find the period of cosine squared, which I'm going to show you how to do. And then you're going to find the period of sine. These are your periodic terms. 1 is not a periodic term. 1 is just a number. Okay? Periodic terms are trig functions. Okay? And then after you have the period of each periodic term, okay, the problem we're going to do has 2. Okay, you could have 3. Okay, it depends on the problem. The period of the entire problem is the least common multiple of all the periods. Okay, it's the LCM. Okay, so let's say we had something with a period of pi and something else with a period of 2 pi. If you're confused, make a list of all your multiples of pi. 1 pi, 2 pi, 3 pi, 4 pi, and so on. And make a list of all the multiples of 2 pi. 2 pi, 4 pi, 6 pi, 8 pi. So in these lists, what's the smallest number they both have in common? 2 pi. Okay, 2 pi is the LCM. It's the least common multiple of pi and 2 pi.
Can you make that bigger? Thank you.
Okay, so any question on that idea? Okay, and 2 pi is going to come up a lot. Okay, for most of the problems we do, that is the answer, but it's not always guaranteed that that's the answer. Okay, does everybody have that? Okay, so just find the LCM. All right, and because some of our trig functions are going to involve higher powers, okay, if this cosine squared wasn't here, we probably could do it, but that throws it off a little bit, so I'm going to show you the formulas, what happens when you have higher powers. All right. So this is all for even powers. Doesn't matter what the even power is for sine, cosine, secant, cosecant, and this also happens to work for tangent and cotangent. Doesn't matter if it's even or odd. Okay. We always use the formula pi over b to find the period. All right? So if you had like sine squared, that's the formula you're using to find the period. We know for sine it's different. Sine is 2 pi. Sine squared would be pi. Sine to the 4th, we would use pi over b. Okay? Sine to the 12th, pi over b. Sine to any even power, this is your formula for finding the period. Okay, and this is the formula you use most of the time, pi over b. Really, the only time you don't use it is if you have one of these cases. Sine, cosine, secant, or cosecant to an odd power. If you have one of those 4 cases, sine, cosine, secant, or cosecant to an odd power, that's when you use 2 pi over b. Okay, and I put b in absolute values. Most of the time we're not going to have negative b anyway. But remember, the period, it's a length. Okay, so we wouldn't want to think about length as being negative. Okay? Period is the length before it starts to repeat itself. And also, can somebody remind me, where is b?
Sine of 4x.
Yeah, it's the number in front of x. So I can write that down. B is the number in front of x. Okay, in every one of these problems, b is 1. Okay, I didn't put the number in. All right, so the reason we need to figure out what the period is of each term is because that's going to tell me what to set my window to. Okay? If I can figure out the period of this problem, that's basically going to tell me, okay, where my x min and where my x max should be. and then I'll graph from there. Okay, so let's start with the first term. Cosine squared. If you want to pretend like there's a 1 in front of t, you can. What's the period of cosine squared? Pi over b. Yep, that's the formula you use. And what's b in this case? Well, b's got to be a number, remember? 1. Okay, that's cosine squared 1t. We usually don't write the 1 if it's just a 1. Okay, so Upi said to use this formula, which is correct. In this case, b is 1. So what's the period of cosine squared? Pi. Okay. Now, this says sine t. If there's no power, what do you assume the power is all the time? 1. Okay, this is sine to the first power, if you want to write it in, but we normally don't do that. Is that an odd or an even number? Odd. Sine to an odd, we use the formula 2 pi over d. It's the one we always used to use. Okay. So what's the period of sine? 2 pi. And now what's the LCM of pi and 2 pi?
2 pi?
2 pi. Okay, remember, the LCM has to be greater than or equal to all the other periods. It can't be smaller than any of the individual periods. Okay. All right, so now that tells me my window should be 2 pi units wide, okay, in order to get all the answers in one period. Okay, so I'm going to set my window from 0 to 2 pi. Okay, I'm already set. If you wanted to go negative pi to pi, you could. Technically, that is 2 pi units wide, but I usually go 0 to 2 pi. Okay, and now we just type it in. We got 2. Then in parentheses, I'm going to put cosine of x squared. Okay, I want to make sure that that 2 is not inside the parentheses, otherwise that would be squared and become a 4. Okay, we don't want that. So 2 cosine of x squared plus sine of x plus 1. Okay, any question on that?
Is it sine of x plus 1 or sine of x parentheses plus 1?
Yeah, the plus 1 is on the outside. If they wanted it on the inside, they'd have to do something like that. Okay? But yes, that would make a pretty big difference. All right, now let's figure out the highest that this function can go. All right? What's the highest that cosine normally goes? Negative 1 is the lowest. Okay, so 1 is the highest. What do you get if you square 1? 1. And if you double it?
2.
Okay, so this part could hit 2. What's the highest sine goes? 1. And that's 1. So 2, 1, and 1. So if everything lined up just right, the highest this could really go is 4. First part can go to 2, second part 1, and the last part is always 1. So I'm going to set my y max at 5. And let's see, the lowest this could go, well, the lowest this can go is 0. Okay, because you're going to square something. And if you square a number, it's never negative. So this first term is never negative. The second term could be negative 1. And that term is always plus 1. I don't think this is going to go any lower than 0.
Nope.
Okay, we can check. I don't think it does. And I don't think it goes down below. It probably just touches it and comes back up. Okay, so that's our graph. And now we've got 2 answers. Okay, I'll get the first one. If somebody can get the second one, that'll speed us up a little bit. So we got 4.12. Okay, and anybody get that second answer?
Where'd you put 4 y, no y2.
Nothing in y2. Nope. You don't need y2 because we're just finding roots.
So what is the red line?
What's the red line?
Oh, you're right. What is... Oh, I think, was that left over from the last problem? Yeah. Oh, I'm sorry. We don't need that.
We could just calculate the zero then, wouldn't you? Because you just need to find the zero.
Yeah. Yep.
So I was going to say.
I got confused from... So if you had anything left over from the last problem, yeah, it's a good idea just to clear that out. Yeah, as Cheryl said, we're just going to calculate that root. Okay, so pick a point to the left. Pick a point right. And hopefully that looks a little better. 4.71. Anybody else get that? Okay. All right, so this time there is only one answer per period. Okay, and what's the period of this entire problem? What do I need to add on the end?
2 pi.
2 pi.
Right.
Okay. And that's it.
2 pi.
So what did we use the 2 pi for?
The 2 pi, we used it for two things. One, it's part of my final answer. Okay, it's going to go on that. And it tells me how wide to set my window. Okay, so we use it for both those things. Okay, so sorry about that red line. That should have been cleared from the last problem. Didn't need that. Okay, any other questions on that one? Yep.
Why is cosine pi?
Why is cosine? Pi is the period of cosine squared. Okay, because it's cosine. It's cosine to an even power, and remember that's the formula we use, pi over b. Okay, if it was cosine to an odd power, we'd be using the formula 2 pi over b. Okay.
I'm not doing the same one.
You're getting the same thing? You got something different? All right, let's try another one and see. Make sure you're in radians if you're getting something different. Okay, we're not in degrees. All right, let's try this one. Okay, this one I'd like to solve just like we did the last one. But in order to do that, what do I have to do first? Yep, what? Yeah, we could either subtract tan x and put that on the right, or subtract 3 cosine x and put it on the left. It doesn't matter how we do it. Okay, what's the period of cosine? 2 pi over b, in this case b is just 1. What's the period of tangent?
2 pi?
Nope, not 2 pi.
Oh, no. Pi over b.
Pi over b. In this case, b is 1. Okay, so pi. So what's the LCM here?
2 pi.
Yep, again, it's 2 pi. So we're going to use that for two things. It's going to be put onto the final answer, and it tells me how to set my window. Okay? The difference between your x min and max should be 2 pi. Right, I'm going to leave 0 to 2 pi. Now, cosine is bounded. Okay, what that means is it has an upper and a lower limit, 1 and -1. We're tripling it, so it's between -3 and 3. But what about tangent? Does that have an upper limit? No, that's the graph that looks like this. So this graph is going to have asymptotes. All right, so what I would do is maybe just set my y min and max like -10 to 10. Okay, it's going to go up and down forever. Let's try -10 to 10. X min looks good. Then 3 cosine x minus tan x. Okay, and remember, we're looking for how many times it crosses the x-axis. Okay, how many solutions does it look like we get there? 2. Yep. Okay, another way I can check the period, make sure I get it right, is it should end right where it started. So imagine copy and pasting this graph, and then it would continue. It's almost like I've broken this part of it into two pieces. But that's fine. Okay. So just find both answers. Okay, so there's that's actually my second answer, 2.13. And what goes on the end of it?
Pi.
Plus 2 pi.
Your LCM, 2 pi k. Okay, and x is about, anybody get that first answer? Let's just see. So we get 2.13 and 1.01. Okay, you just go through it and find the root just like we did the first one. Okay, when we do a problem that has lots of roots in it, like 5 or 6 of them, I'm not going to find all of them. I'll read off what they are. I can do one of them if you need me to, though.
So, why is 3 cosine x 2 pi?
So the 3 doesn't affect the period at all. Okay, that's just a vertical stretch by a factor of 3. So this is cosine to an odd power.
Okay.
Right? So we look up our formula,
Yeah.
cosine to an odd. That's where the 2 pi comes from.
All right.
Okay, and in this case, b, I didn't write it in, but imagine an invisible 1 right there. Okay. All right, so here's a problem where there's a periodic term where b is not 1. Okay? B is 2. Right, so what's my formula for sine to an odd power? 2 pi over b. And Jamie, what's b in this case? 2 pi over 2. Right? So in this case, the 2's cancel, and my period of sine cubed is pi. Sine cubed 2x. Questions on that one? So we use the formula 2 pi over b because it's sine to an odd, and in this case, b is 2. So the 2's canceled. What's my period of cosine? It's cosine to an odd. That's the 2 pi over b, so my period is 2 pi. Okay, if you want to think of it, it's cosine to the first, cosine to an odd, 2 pi. Okay, any questions on getting my individual periods? Okay, now, what's the smallest multiple that pi and 2 pi have in common? 2 pi. Okay, so that tells me what to add on the end of each answer, and it tells me what to set my window at. All right, so let's type in 3. Let's clear that. Okay, 3 in parentheses sine 2x cubed minus 2 cosine x. Okay, I'm going to look for how many times this graph crosses the x-axis. Okay, this one's going to cross quite a few times. We could leave our window -10 to 10, but let's do -5 to 5, just to zoom in a little bit. So we get 1, 2, 3, 4, 5, 6, and that's it. Okay, so this one crosses 6 times. Okay, there's your graph. Okay, and I'm just going to read off what the answers are. Does anyone need me to show you how to find a root again? Okay, you'd have to do it 6 times. I probably wouldn't have one that has this many. Usually, it's the way it worked out. All right, so our answers are at 0.50. 1.25, 1.57, okay, 1.89, 2.65, and 4.71. So it might be good on your own if you have time. Just try to calculate one of them and make sure you know it works out. And then on every one of them, I'm just going to put plus what goes on the end of all of them. Yeah, so I'm just going to write it like this. And just understand that that means plus 2 pi k on everything. Okay. Any question on that one?
Can you scroll back up for a second? I just didn't quite read what the powers are.
It's sine cubed. That's the only power. Everything else is to the first. Yep, 3. Yep. Okay, any other questions on that? All right, so if we can do equations, okay, solving equations using the calculator, we can also solve inequalities. Okay? It's basically the same thing. You have to graph it, except your answer is going to be an interval. Okay? So like in this last problem, if I said to you, tell me where this function is above 0. Just put a copy over here and make it bigger. Well, I would find all these roots, okay, just like I did. And where is it above 0? I would say between these two. So what's that? Between 0.5 and 1.25. Between these two. And between these two. All right? And I just have to write that as 3 separate intervals with the union. Okay? Between 1 and 2. Between 3 and 4. And between 5 and 6. Now, if I asked you where is it below 0, I would say from 0 to the first point. From the second point to the third point, it's below. From the fourth point to the fifth point, it's below. And from the sixth point to where my window ends, it's below, which is 2 pi. Okay, we just have to be careful whether we use a bracket or parenthesis. If it's equal to, okay, we can use the bracket. If it's not equal to, just make sure you use the parenthesis. Okay, any questions on what we're going to try to do? Okay, and keep in mind that if it's below 0, let me just scroll down a little bit. If it's below 0 between the second and third point here, this same behavior is going to occur again over here, and then again further down. You're going to see the same graph repeat. So just like we did with a point, you're going to put plus pi k or 2 pi k on your interval. Okay? You do this exactly the same thing. All right. So let's try this one. Yeah, I don't have to get 0 on one side, but that's the way we've been doing it. So I think we should stick with that. Can somebody tell me how can I get 0 on one side? Subtract something, doesn't matter which one. Let's just move sine x to the other side. Cotangent x minus sine x. So I'm going to be looking for where my picture is greater than 0. Some people like to write it this way. Those two inequalities are the same thing. Just switching. All right, so let's type it in and see what we get. Okay, first thing I got to be able to type in is cotangent. How do I type in cotangent since I don't have a button for it? Yep, I'm going to put it in parentheses. 1 divided by tangent. Okay, so that's cotangent minus sine. Okay, and we're going to look for where this graph is above 0. Is this graph going to be bounded, or is it going to have asymptotes and go off the screen?
It's going to have asymptotes as in the tangent, right?
Right, because of that cotangent function, it's going to go off the screen, so Don't try to see the top and the bottom. You never will. I'd try -5 to 5. And for our window, do the same thing we did before. What's the period of cotangent? So it's cotangent to an odd power.
It's pi over b.
Pi over b. Yep, and in this case, b is 1. What's the period of sine? Sine to an odd power.
2 pi over
And what's b in this case?
1.
1. Okay, so my LCM is, shows up a lot. So that's what you're going to have to add onto each interval. And that's also going to be my window, which I already have. Okay, so say graph. Remember, we're looking for where it is below 0. Okay. All right, let's do that. Okay, how many spots here is it below 0? 2. Okay, we need to find this point, and we need to find that point. Okay, let's start with this point. Okay, so we got second calc 0. Okay, and we're at about 0.90. Remember, it's the x value, 0.90. Now, can we equal 0.90, or is it strictly a greater than or less than? Yeah, this one is just a greater than. So would that be bracket or parenthesis? Parenthesis. Okay, now it's 0.90 up to a certain point. Okay, remember, there's an asymptote, so it's 0.90 up to that asymptote. So this is where we have to remember what the asymptote is for tangent. Okay. You could also kind of look at it, our window is 0 to 2 pi. This asymptote looks like it's right in the middle of the screen. So,
Are we finding where it's greater than 0?
Greater than 0, yes. Thank you, I was doing less than 0. That's okay, we still need this 0.90 though. So now I want to focus on this part. Thank you. What's that left edge of my window?
0.
Yep, from 0. And is 0 part of my window? Yeah, if you go to your window, the x min is actually at 0. So we can include 0 up to, but we're not including 0.9. Okay? And now this is the second part. So we're going to be above 0 from the asymptote. So we still need to find that up to the second point. Okay, any guess what this asymptote would be? Because it's right in the middle of my screen.
2 pi.
Let's try pi and see what happens. Okay. If you try to trace to a number and the y value is not there, that means it's undefined. Okay, so the asymptote is at pi. Right, so we can't include pi. And we're going to go up to that point right there. And we also cannot include that. Okay, does anybody have that second root? No. So just find that. If you can't find where you're at, if you just keep pressing left or right, eventually it'll pop up on the screen. 5.38. Okay, the way I was doing it originally, I was going to do where it was less than 0, which would be 0.9 to 3.14 and 5.38 to the edge of my screen. Okay, and that behavior is going to repeat how often? Yeah. Okay, so what I'm going to have you do, you can write it like this. This is not how the book does it. They actually put plus 2 pi k 4 times on each number. I just put it like that. Just put it on the whole interval. If you want to write it on each number, that's fine too.
Can I just see what you punched in for Reagan?
Okay. Any questions on that one? Yep.
So how come you included 0 but not use them on 4? They're both right.
Yes, thank you. Actually, that technically should be a parenthesis. You're right. Okay, because at 0, Cameron just mentioned there is another asymptote right here. So technically 0 should be a parenthesis, but everything else is fine. Thank you. It's a good catch. Okay, so there's a lot of little things, even for me. Sometimes, you bracket, parenthesis, there's a lot of little things to be careful with. Something like that, you wouldn't lose much credit on a test for. You'd lose 1 point, bracket versus parenthesis, but still one point. Okay. Any other questions before we look at our last problem? All right. So this one, let's just practice graphing it as is. Okay, don't rearrange anything. Just leave it the way it is. And now the term on the left, that's a sine function. Okay, so that's going to have behavior that repeats itself. How about what's on the right? This is a parabola. Do parabolas repeat? No. When you graph a parabola, you don't see multiple parabolas on the screen like that. Okay? So what's going to happen is this interval, it's going to be one answer. Okay? Because we're dealing with a function that repeats and a function that doesn't. So we're only going to get one answer to this problem. No plus 2 pi k. So I'm going to put sine 2x in y1, put my parabola in y2, and I'm looking where my sine function is above or equal to the parabola. Okay, let's just do zoom 7. Okay, that should be fine. Okay, so in that case, if that's the problem they gave us, where is the sine function above the parabola? Never. Okay, so if that was the problem, it would be no solution.
Is it equal to it?
What's that?
It looks like it's equal to 0.
Actually, there is a small gap there.
There is.
Yeah, they don't actually cross. So what I'm going to do, I'm going to change what the book gave us to make it, we can actually do it. Make it a -1, and then that parabola is going to be shifted down, and then it should work. Okay, so just to be clear, the way the book gave the problem, there's no solution to that, which can happen. Yeah, but let's try it this way. So we got our sine function. And now I want to know where the sine function is above the parabola. Right, so what would be my first step? What do I have to find first? Yep.
Finding the two intersecting points
Yep.
where it intersects the parabola.
Find this point and find that point, which, let's see, do they give me those? Negative, this is at negative 0.46. And the other one is at 1.26. Okay, so we did our intersect. We've got the two x values. And how would I write my answer now? Where the blue function is above or equal to the red. Tell me how I would write that as an integral. So we're going to have 1.26. That's part of our interval, yep.
Pi T.
And where is the interval start? Brendan?
Discussion.
Where's that interval start?
What?
Where's the interval start for where the sine function is above the parabola?
Negative 0.46.
And can we include that?
Yes.
Yes, because it did say greater than or equal, and we can include that. There's no plus 2 pi k, because you're not going to get another parabola down here again later on. That's the only place that the sine function is above the parabola. For the rest of the problem, the sine function is just going to stay below, and below on that side as well.
So if we don't have two functions, we don't have to get a period?
If you don't have two periodic functions.
Yeah.
Yeah, a parabola is not periodic.
Okay, so
No.
if it's like this, you just grab it.
Yep. So if you had like a line in here, or a parabola, or a circle, things like that, they don't have periods. Just sine, trig functions have periods. That's it. Okay, any other questions on that one? Okay, so pretty much every problem today was using graphing calculator. All right. So the homework, okay, it's all graphing calculator. Okay, it's on 401. It's 5, 7, 12 through 15, 19 to 23, just the odds, 29, 31, and 33 to 37, just the odds. Okay, we'll take a look at that first thing tomorrow. Okay, tomorrow we'll also finish up everything we're doing for the week, and then Thursday is going to be a review day for the test on Friday.